This video would give you a broad overview of the JavaScript language. We would talk about why JavaScript is the de facto language of the web, why it is dynamically typed, why it is weakly typed, and why it is just-in-time compiled in most of its implementations. We will discuss the various names that are used for JavaScript, the fact that it can be used both at the front end and the back end, and the fact that new additions to the language always have to be backward compatible. We will in fact use a fun little visual metaphor to illustrate what we mean by backward compatibility. We would finish off by discussing the fact that JavaScript has evolved into a powerful general-purpose programming language over time, and we will also mention some of the challenges that you might face when learning the language for the first time. If you're interested in seeing more videos like this, please subscribe to our channel. The following is an extract from a web-based course I'm putting together at the moment called JavaScript for Visual Learners. What are the key characteristics of JavaScript? If you want to look at the language from a bird's eye view, looking at the forest rather than the individual trees, we can think of JavaScript as the de facto language of the web. This is probably the thing that makes JavaScript the most special. If you're doing almost anything web-based, it would not be long before you would realize that this is a language that you would have to learn and you would have to master. From its inception, JavaScript has been designed as a language which should be fairly easy to learn for a non-programmer, which has determined a lot of its design choices. For example, JavaScript is dynamically typed. Now, what do we mean when we say that a language is dynamically typed? What we mean is that we are only checking types. For example, is something a number? Is something a string? At runtime, one line at a time when that code is in fact run. This is in contrast with statically typed languages, where we check types before we ever run the program. JavaScript is also weakly typed. When we say weakly typed, what we mean is that JavaScript would often be making changes of types for us, which is called type coercion, which would allow us to do things such as add a string to a number and then end up getting a string without the program complaining that we are mixing types. Many languages do not allow that. Most modern implementations of JavaScript are also what is called just-in-time compiled. Now, what do we mean by that? When you take the source code of a program and then you try to convert it to machine code, there are two basic ways of doing that. One of them is using a compiler, where you would take the entire code before the code is actually run. You would check for types and errors and things like that, and you would very often optimize it. And then you would run the code. An alternative approach to this is to use an interpreter. In this case, what you would do is the computer would be converting each line of code sequentially into machine code. So the code would be run line by line when all of things such as type checks would be done at this stage, at runtime. When I try to think of concepts such as compiled or interpreted, I always like to use analogies. So, for example, imagine that you are organizing a trip for a head of state, let's say a president, that has to visit 5 cities. Very often this type of trip would be compiled. What do I mean by that? There would be a plan ahead of time. Somebody would check and double check the plan, make sure that everything would work, make sure that all of the streets would be open at that time. And this is what a compiled program tends to do. It does a lot of checking before we actually run the trip, before we run the code. You can think of an interpreted program, on the other hand, like going on a road trip with your friends, where you still plan to visit the same 5 cities, but you sort of check for errors at runtime. For example, you might discover that there is no train going from city A to city B. So what then is just-in-time compilation? Well, you can think of it as having the best of both worlds. You still run the code line by line, but then you keep looking ahead for improved efficiencies. It is like getting to a train station, seeing that there is a large queue of people there, and before you even line up, getting on your phone and starting to check if there is some alternative way to get to the next city, alternative transportation. To go back to real code, think about, for example, a loop that calls a function many times. Initially, we would call the function the interpreted way, and we would go through every single line of code in it. But soon, the JavaScript engine would notice that we keep calling the same function again, and it might find an optimized way to get the result back. This would be an example of just-in-time compilation. Now, what I just did was give you a very high-level overview of some fairly complicated concept. Dynamically typed, weakly typed, just-in-time compiled. I don't expect you to fully understand what these things are now, but the point is to get you at least acquainted with these concepts, and maybe you can read more about them later, when the time comes. This is one thing that you would find you would have to do all the time when you're learning to program. You would get acquainted with something and then you would revisit it many times until you fully understand it. Something else that you have to be aware of when you first start learning JavaScript is that JavaScript is referred to by more than one name. Sometimes we refer it to as JavaScript or JS, but sometimes we refer it to something called ECMAScript or ES. Now there is a whole lecture which goes into that topic, so I don't want to be spending too much time on this now. But the idea is that ECMAScript is a standardization body. JavaScript is in fact a standardized language. So very often when we talk about the standardized version of JavaScript, we would be referring to it as ECMAScript. For example, when browsers put together their JavaScript implementations, they will be consulting the ECMAScript specification so that they all follow the same behavior. Each browser writes their own implementation, so it is important that we have some consensus about what a browser is supposed to do with a web page. There is one peculiarity about web languages which makes them a bit different from, for example, compiled languages. If we update the language in any way, we have to make sure that code written previously on older websites still continues to run. You can imagine that there would be a big problem if every time the language specification changes, all of the websites that use JavaScript before that stop working properly. So the point is that JavaScript has to be backward compatible. We can improve the language, but we always have to make sure that the previous decisions that were made there are still active. The old code still works. Now, as I've mentioned before, I always like to think of metaphors and analogies when I try to learn something. I was thinking of a good way of explaining backward compatibility in something that is a bit more intuitive than language design itself, and I came up with the following. Imagine that you wanted to escape the city, so you build a nice little house in a beautiful nature spot. There you can spend time doing one of your favorite things, which is to ride your horse around your property. Times change and the city you tried to escape from is growing. All of a sudden people want to move in the area, and then you decide to become a developer and to build a building. But remember, unlike real life, everything has to be backward compatible. So you build the building, but you keep the foundations of the house, and the horse, and the trees. You build a staircase, and then you build a pool. But the building that you built did not have an elevator, so now you need to have an elevator. It turns out that the people really want one. So you can move things around, but you still have to keep everything that was there before, the pool and the staircase. It turns out that some real wealthy people want to live in the area, so you decide to build a helicopter pad. But it also needs an elevator, so to build the elevator now you have to cover up the pool. So all is great, you have a beautiful apartment complex. But its internal design has been affected by all of the choices that were made previously. Remember, we started with a simple house. For example, our building now really has 2 elevators. And it also has a horse that you can ride around your property in. It's all still there. The evolution of JavaScript has in fact followed a similar theme. Design choices that were there initially are with us to this day. Yet the first versions of JavaScript were for a simple scripting language. Nobody was thinking that we would be building complicated applications using JavaScript. The plan was to in fact do this using Java. But history turned out to be different. JavaScript not only became the de facto language of the web on the front end, but is increasingly being used on the back end. And it has in fact built a huge ecosystem of libraries and frameworks. JavaScript is not going anywhere. The increased use of JavaScript for sophisticated web applications has also greatly affected its design in recent versions. JavaScript has in fact now transitioned into a fully capable general-purpose programming language. Competition between browsers has also resulted in JavaScript engines which are incredibly fast. All of this has been great for the language and for its adoption, but unfortunately some of the issues with backward compatibility remain. JavaScript is no longer that easy to learn. It has ballooned into a fairly big language, and yet we still have to be aware of older implementations. And then we have the huge ecosystem we talked about. Especially on the front end, people are finding all of the things that they have to learn and master a bit overwhelming. But remember, many of these tools are still based on JavaScript, so getting a good, solid, foundational understanding of the language would end up being a big time saver in the long run.